In this video, we're going to talk about something called the Coolidge Tube, right? And the Coolidge Tube basically is a device that is able to produce something called X-rays, all right? And these X-rays are then going to fall onto something of a spectrum like this. And from this spectrum, we will be able to identify the nature of this metal over here. And so let us first understand how the Coolidge Tube works. Let me first bring your attention to this. This is a heated cathode. Okay, a heated cathode is just something that can produce electrons. And so these electrons are going to be emitted from the cathode. And so you can see, I applied a potential difference, like so. And so these will accelerate these electrons to bombard with this metal over here. And in the process of this bombardment, it's going to be very energetic, and it's going to release these high energy photons, which are X-rays. As you all can probably remember, X-rays are on the high end of the electromagnetic spectrum, and since E equals to HF, right, you can expect these photons to be extremely energetic. One more thing that we need to pay attention to is that there is a cooling system over here, and the reason why we have this is because of the sheer amount of heat that is produced in this bombardment. Without the cooling, this thing will increase its temperature at an incredibly ridiculous rate, and your metal will melt before you know it. And so the water in and the water out makes, or should I say, helps to release this heat or absorb this heat more effectively. And so these X-rays, upon an analysis, okay, we're going to get a spectrum that looks something like this. So if we plot the wavelengths of the photons detected with intensity, you're going to get a nice little shape that looks a little bit like that. Okay, we will talk a little bit more about this spectrum in detail, but basically the key components of this spectrum is, number one, these two things, which are called the characteristic peaks. And it is from these peaks, looking at where they lie on the wavelength scale, that you will be able to identify the nature of the metal. There is also this nice little curve at the bottom of here. This is called the continuous spectrum, which we will talk about as well. And there is also one last thing. The continuous spectrum cuts off abruptly at some lambda naught, which is what we call the minimum wavelength, and we'll also understand why there is a minimum wavelength.